First, about myself, I graduated from Polytechnical University last year, and I've been working at company StarLine in St. Petersburg for 2 years since I was at my 4th course of education. And there is a beautiful symmetry because I'm going to talk today about a project we've just started. We've just started at June, and we bought our car actually at September. So there's very few work has been done yet, but yet I want to share, I'm eager to share our idea with you and our architecture and our plans and what we have already done about our car. Before we start, I first would like to share some dictionary with you that is used in autonomous vehicles industry. And then I'm going to tell about our project in 4 steps. And then I'll tell you how we at StarLine see the future. And that's going to be the end of my presentation. We're living in a century when autonomous vehicles are no longer in the domain of science fiction. The automotive industry is changing right in front of your eyes, and changes in dependent industries will follow, as well as urban environment is going to be reshaped. And we at StarLine are going to face the challenge. Autonomous means self-governing, and autonomous control implies satisfactory performance under uncertainties in the environment, and the ability to compensate for system failures without external intervention. And in the industry, there are 50 levels of automation because there are more automated cars and less automated cars. So there are actually not 50 shades, but only 6 levels of automation distinguished. Level 0 is base. Driver controls everything, the wheel, the throttle, the brakes, and all other controls. This is just any ordinary car you can find nowadays in the street. Level 1 is driver assist. It's called driver assistance. Driver is fully engaged, but can give up some of the controls. But vehicle supports the driver with either steering or acceleration. Cruise control, for instance, is level 1 automation. It automatically adapts speed to maintain a safe distance from a car in front of your one. Level 2 is partial automation. Car can brake automatically, accelerate, and unlike level 1, take over steering. According to the standard, a vehicle can control both steering and acceleration. So suppose you're driving and you get distracted by your wife or husband or children or whoever, and you lose your control over the car, you lose your concentration over the road, with the road. And that's the very moment where lane keeping assistant can take over the control and drive the vehicle for you, because the engine can see the lane, can see the road marks, and understand where the middle of the lane is. And such systems can be found on market already. Buying a premium vehicle, a premium class vehicle, you're probably going to buy level 1 or level 2 automation as well. But the true autonomous driving begins at level 3. It's called conditional automation. The vehicle drives autonomously, but the driver has got to be ready to take over the control whenever is necessary. Level 4 is high automation. The vehicle controls all aspects of driver experience, and there is no expectation that human driver will ever intervene. At this level, it's already possible that the vehicle will have a steering wheel, throttle, or brake, and it's possible that it will have no. However, at this level, the vehicle may be restricted at certain areas. Within the area, the vehicle can operate completely autonomously, but outside, the car is either unable to operate autonomously or unable to operate at all. And level 5 is full automation. The vehicle can operate completely autonomously and in any area that human can drive. And the first 3 levels, from 0 to 1, can be found now in production. And level 3 and above, level 3 is only appearing on the market, and level 3 and above is where autonomousness kicks in. So what we're doing in StarLine, we aiming at level 4 autonomous car. And I'm here to introduce you the StarLine open source car platform. And before I start, I'd like to notice that StarLine is not building an autonomous car alone. We're building a whole technological platform which includes our autonomous vehicle, and we need our car to develop and test it, but it's more than just a drone, actually. Look, the first levels are works on the car itself. It's about investigating its hardware, installing its equipment on it, exploring internal digital interfaces. The second level is about hardware we're going to install, and it's going to be embedded in at the third level is creating programs which are going to be embedded in a car and ride with it in its trunk. And the last levels are both client and server apps. And excuse me, it's my first public talk ever on technical part, and I'm a little nervous. And we call this platform OSCAR, and it stands for Open Source Car, because we're going to open every single line of code concerning the car to community. And it's unique, because most of the development of autonomous cars is held closed. So you actually can't access them, and but there are several open projects, though. So, how do you start when you want to build an autonomous car? Seems like you can choose any, but actually you have to be careful selecting the car itself, because the particularities of a vehicle can prolong and delay the development. For instance, you can choose a car with a mechanical transmission, рычаг управления, and you'll have to do a lot of unnecessary works rebuilding the mechanics instead of working on the car itself. So first of all, we wanted a car to have as less mechanics in control as it can. The second request was a car which already had some level of automation, which would help us to reverse its internal digital interface. And we also wanted a cool one. So the team is enjoying riding it, rebuilding it, breaking it down, and I put a first scratch on its door. It was just priceless. But how to control a vehicle, actually? There is a communication network inside the car, which is called the Control Area Network, or CAN bus. In a nutshell, it's a digital bus inside the car, and all devices inside the car, like power steering, doors, windows, mirrors, adjustment, wherever, they are connected to it in parallel. They can some of them can send, some of them can accept and listen to commands and react to them. And to control vehicles' acceleration and steering, you need to access the CAN bus and know the relevant package types to send right commands. And our guys now are investigating its protocol. As I already mentioned, we started in June, and the car was purchased in September. So it was just September and November. In 2 months, we already mastered steering by small angles, acceleration and deceleration. Now our guys investigating steering by larger angles, and this is my colleague Dmitry on the left. He's not touching the wheel, honestly. He doesn't. I know the picture is not the best quality. And his colleague Gramil at the passenger seat is using his laptop to steer. And it was like 10th October, so it was 2 weeks ago, and that is the point of time when we already could steer. But by now, we already know how to accelerate and brake. So let's talk about hardware a little bit. There should be also some sensors to give the car a vision of what's going on in the surroundings. Since we've obtained control over the car, we now want to outfit it with something. Some of the sensors are purchased right now, and we are calibrating and tuning them. So what is going to be like? There are going to be 2 radars in front and on top. There are going to be a bunch of cameras and a box on top with a LiDAR, inertial measurement unit, inertalka, satellite navigation, and odometer, which I forgot to mention. This is our car, and this is our sensors are going to be installed. So let's start with satellite navigation, because I believe is the most important part. Probably you know how GPS works. GPS actually receives signals from at least 4 satellites. That would be enough. And it determines the vehicle's position from the signals. This signal contains satellite's precise time and position, and not the position, the parameters of its orbit. And so the GPS receiver, knowing the time delay, since the signal left the satellite and it arrived in a car, the GPS receiver can compute its precise time and position. And the first problem with civilian GPS is its significant error. Even in perfect conditions, under a clear view of the sky, its accuracy is approximately 5 meters. But with accuracy like 5 meters, you can end up on a sidewalk hitting things. And that's actually what's happened with any GPS, both civilian and high-precision GPS in urban environment. It's imperfect because some of the signals get reflected from buildings, and when they reach the car, the time delay is enlarged, and that gives you an error like this on the left. This is a real picture from our servers, and when you order a Yandex taxi and it's wrong with the side of the street, that's actually what Yandex has to filter out from your GPS signal. Well, I believe, because I don't know how it works in Yandex, but in our monitoring service, it works like this. And sometimes you can also find yourself in a tunnel or in underground parking where a detector is not going to see satellites at all. And also points arrive from your detector several times a second. So you have extrapolate your position somehow between them. And that's the way, that's why we have to use other way to localize the vehicle. And on the right, you can see our high-precision GPS receiver. We're using it to ride around our office on Vyborgsky district. So it's already fine, but we're still tuning it, and it's going to be installed in a car very soon. So, excuse me. To refine your position between, you get the points. You're using the IMU, inertial measurement units, and odometry readings. Inertial measurement units can measure your acceleration, and it can integrate the acceleration to the device to calculate its velocity and movement. And to refine the data even more, car uses odometer readings. This way you can position yourself with a centimeter accuracy most of the time, and in the beginning, for the first prototype, it's going to be enough for us. By the way, the problems are known to the manufacturers, so these 3 devices are brought together in one box. And I forgot to place how it looks. Okay. Anyway, so once the car is localized and we want to understand if there are any dynamic moving obstacles around, radars and lidars are used. Radars use radio waves to detect obstacles, and due to Doppler effect, it also allows to estimate the radial velocities of objects. It's a cheat the lidar doesn't offer you, but in some approaches, lidars are also used. Imagine a laser ranging device like you probably used to redecorate your apartment to measure a distance from wall to wall. The laser beam is emitted from device and meets the obstacles, then gets reflected from it and comes back to the sensor. This is the way you can measure a distance to the obstacle. Now picture such sensor resolving around its axis to create a collection of individual measurements. This is LiDAR, and it's creating such a collection for you, which is called a point cloud. Here the point cloud is on the picture. But unfortunately, the presence of moving parts in LiDAR makes it both wear-prone and expensive because you have to mechanically stabilize the system. And this is also the reason why LiDARs use more power. And the cheapest device can cost you approximately 7,000 rubles. 700,000 rubles, almost a million. And for an autonomous car, you need several of them. So when you're trying to build an autonomous car from Lexus, the cheapest part is actually Lexus itself. So what do you use LiDAR for? First of all, it can be used to refine obstacle detection. Whatever light reflects off, laser beam does too, so you can get yourself better informed of the world around you. And The second thing what you can use LiDAR for is all of a sudden a high precision localization in a special kind of map used for self-driving. Let me give you some examples. Suppose you already have a good amount of sensors installed in your car and you're moving down to a crossroad to see another car. Now, who's supposed to give the way? The one who's on the main road. But in many cases, determining which one is the main road is not a trivial task for a non-human driver. Or another example. If you want to detect a traffic light in a picture, you have to scan all parts of the picture, several pictures a second, and it's actually computationally expensive. And it would be great to at least know the direction in which to search. And suppose we found a traffic light. Now the algorithm has to make a choice which one concerns the vehicle, because there are usually more than one traffic light as the crows turned in different angles, to you, from you, at the angle to you, and they sometimes have different colors in them. And it would be great to actually learn about the objects of the infrastructure without using the computer vision. What if the map could tell you all about it? Locations of signs so you can know the direction to search in and which one is the main road. Now, what if the map could also tell you all about the particularities of the road, like holes in the pavements and heights of curves? And HD Maps is a map which solves the problems. It offers a complete centimeter accuracy depiction of real world, including all things relevant to road navigation, such as lanes, signs, positions of traffic lights, and road boundaries. It can also contain LiDAR data to provide you insight of what the world around you is. And also, in this case, it can be visualized like this. High-definition maps are essential for self-driving. We are now at StarLine trying to contact commercial map providers to see if any of them have coverage in Russia. Now we've talked about LiDARs and radars and hardware. So how are we going to incorporate the data? This is the, let's talk about software. This is the canonical approach. Consisting of 5 modules, among which are perception, fusion, planning, localization, and control. On the left part, you see sensors, and data from cameras, radars, and LiDARs are used for object detection. This is used, then it's fused to get information about dynamic obstacles which move around on the upper part. And GNSS data and LiDARs are used to solve SLAM problem, which stands for simultaneous localization and mapping. This is an approach for creating a map for an unknown environment while keeping track of devices' location within it. The information is used to calculate cars' 6 degrees of freedom pose, which includes 3 spatial coordinates and 3-dimensional speed. And planning the vehicle's local trajectory is next, and the final step in the pipeline is control module, which is used to actually execute the trajectory we've built while we did the path planning. The car needs maintenance, and we also want it to be connected to our servers, and that's why we're building also a server infrastructure for it. Our cloud is going to include a storage for HD map we're going to collect while we'll ride in Vyborgsky district again, when we will get a LiDAR. And it's going to include also telemetry API, Commons API, interfaces, and simulation module. This is the very first layout for our server architecture. You see the storage for maps. And metadata DB is going to store the readings from the devices that we have. And we also want to develop a Commons API, simulation module, and user interfaces. Our applications are already able to send some commands to the vehicles, to the ordinary ones, and control some of the function via the CAN bus, like turning on engine and heating up the car when it's cold, open its truck, and others. Commons API are just going to extend functions we already have to perform for autonomous vehicle. We're also planning to place a simulation model in the cloud. Sometimes special simulators or even game engines similar to GTA are used to generate road situations for debugging purposes. With virtual simulation, we can increase the robustness of all our algorithms by testing on large amount of miles in a fraction of time and cost it would take to do on physical roads. This is a picture from such a generator with pixel-wise annotation. And as a user, you would probably like to grab your cell phone, set point A and point B so that a vehicle will arrive and take you to the desired location. And for business usage, if a person is an administrator of a fleet of autonomous vehicles, he or she will want to give tasks, see reports, gas usage and other statistics. And we are now starting out commercial monitoring servers for level 0 cars, but we will adapt it to driverless transportation later. So this is an overview of our platform we're building. There are works on the vehicle itself, on the hardware level, on software, and in the cloud. So where are we at this scheme? We're going to use satellite navigation to localize the car, then build ourselves a path and follow it. It's our plan till the new year. So now we're working on the vehicle itself, on the lowest level, and on the hardware level. And some research is also done in software, in a module concerning computer vision, but it's ahead of plan and not a main branch of our advance. And I'd also like to share some insights about how we at StarLine see the future of technologies of autonomous driving. It's widely believed that people who solve problems concerning autonomous vehicles nowadays are actually solving a much more complicated task than those who will follow. Because it would be much easier if smart cars had smart roads. Imagine vehicles could communicate with each other. This is a picture of vehicle-to-vehicle communication, or shortly V2V, which would comprise a wireless network where autonomous cars can send messages to each other. The transmitted data would typically include speed, location, directions of travel, braking, and loss of stability. These are ideas which hang thick in the air. V2V is often viewed as a mesh network, meaning every node could send, capture, and retransmit signals. And 5 to 10 hops on the network would gather traffic conditions more than a kilometer ahead. And that's enough time for even the most distracted driver to take his foot off the gas. This also can be used to normalize the speed in a chain of cars which follow one another, and that's the way all of the participants can save fuel and oxygen. This is vehicle to infrastructure. There can be different kind of connection. This is a vehicle to infrastructure connection when the road is able to transmit to a vehicle what are signs and regulations. Or as a pedestrian, you could wear an electronic mark telling the car that human approaches. And that way you can be noticed by them in any weather and at night, which makes the road safer. And if a car could be connected to server, it could request server for better planning of the route or finding a nearest parking spot. And if we could try to start with the infrastructure, autonomous vehicles would require less sophisticated algorithms and less expensive equipment. What we're going to see next, I believe, are changes in city infrastructure and level 0 cars equipment. The presence of such things would make them both more reliable and cheaper for everyone. Automotive industry is changing. The industry as a whole will be influenced and cityscapes will not remain the same. We're moving to a more comfortable and safe environment, and it's not a distant future. It's what we're going to experience in our lifetime. Some people are worried about autonomous vehicles. To them, they see unsafe and unpredictable. But your children will probably forget how to drive at all. And if you're interested, you can join our team, and we'll also open the repo in no time, and anyone will be welcomed to contribute to technology of tomorrow. Yeah, sure. Oh, so many of you.
Wow, wow, wow. It works now. Hello. Thank you for your talk.
Yeah.
I have several questions.
Sure. Please give them to me one by one so that I remember the next one.
Okay. First one is a bit boring maybe, but as far as I know, you are allowed to drive on a car like this, like with some modifications in it, only in two cases. One way is to get approval from our government structures, which is like impossible. And the second one is to have some license, or I'm not sure about that. It's like you need to be employed in some institute, and then you are allowed to drive such a car.
You mean the autonomous one?
Yes, yes.
The question is that we are not going to have a truly autonomous car in close time. I mean, in a short period. All the time that you're developing your car, the engineer is at the driver's seat, and he's ready to take over the control.
But as far as I know, it's not enough. Like, if some inspector stops you, you will say that I was driving the car and this laptop is just in case?
I personally unheard of it, but I will learn and I'll tell our engineers, and I don't work alone, so I'll get advice in this field. Okay.
Okay, thank you. And then other question about which technologies do you use, which languages, and how deeply do you reuse some existing decisions, like for navigation or for image processing or something like this? Thank you.
Yeah, I got your question. We're moving to a software layer. You can see 3 layers of software. Excuse me, I'd like to grab my pen because some of the questions, it's my first session in life. So I guess that I'll have to write down some of your questions to pass them to our engineers. Here you see 3 layers. The first one is RTOS. You have to use a runtime operation system for autonomous car, because you want a predictable time of response from it. You don't want to handle the requests forever because you're on the road. The second layer is Runtime Framework. We are using modification of robotic operating system framework, which is middleware, which is used for robotic development. And these 2 layers exist in, as far as I know, in 2 open repositories, and we are choosing between them now. There is one developed by company Baidu, which is a Chinese search engine, and the second one is called AutoWare. And we are now we now tend to choose Apollo, but we're in decision now, so that's why I didn't mention it. And yes, we are going to reuse the existing solution, at least for the first time. Actually, the whole work is held now on the vehicle and hardware, and there is a hardware work, and in software these are going to be modules, and I guess we will write them in Python, but it's not certain yet, and the server infrastructure is going to be done in C++ probably. That's it. Yes. Oh, I cannot choose.
What exactly do you do in the company? If you don't make software yet, what do you do?
We have several projects, and this project has just started, and it's fine for me. The work is done on hardware now. I myself is a Python developer, though I entered company as a C++ developer, didn't like the language and switched to Python. So I'm writing in Python for maybe a year and a half, and I was developing Python. I was developing a Python API and number of Python workers to take data from one database and put into another, for example. That was my job in a company.
Tested it yet with a car? Have you tested it yet with a car?
We're actually now in a very early stage.
Okay.
So it's very, very early.
Thank
you.
Excuse me.
First of all, thanks for your presentation. You did really well with your first talk ever, and also given it in English. Well done. My question is also a tricky one. I looked up your company during the speech, and I looked through what you're actually doing. So is this a commercial project or is it a pet project? Because, you know, there are much bigger companies who are now working with thank you, self-driving cars. And how serious do your company take this project, since it bought you a whole new Lexus, you know? So what are the plans of the company for this project?
Yeah, our motivation...
If it isn't a secret, seriously.
No, it's not a secret at all. Our motivation is first of all, we want to rebuild our internal oh my God, I keep forgetting the words. Our first goal is our staff development, because people get interesting tasks they can work on, and they can master skills they never tried, and that makes our work much more interesting. And that's the first purpose. And the second purpose is actually, as we are a company at the edge between automotive and IT, we are planning to have a lot of side projects coming from this one. This one is not commercial. It's a pet project, and it's a R&D project. But we plan that we will have a lot of outcome of it for our different projects. Like I mentioned, advanced driver assistance systems, which can keep you in the lane, for example. And that's what we can implement on our cars, for example, on our different cars using our devices, because we have expertise in CAN bus. We know a lot of protocols because we can install our equipment on almost every car in the market, and we get certified. And that's our key expertise. And that's why we predict that we will have a lot of side projects coming from that one. So that's our main goal.
So you're basically using this pet project to get a lot of insights in different spheres that can be more like commercial and adaptable to real life, not just the great aim of a self-driving car.
Exactly. That's what we're doing.
Okay. Thank you.
And it's also fun.
That was really good. That was really great. I never saw how like self-driving cars actually work. So thank you. That was useful.
Yeah.
Maria, thanks a lot for this talk. It was really fascinating and interesting. Could you please tell if you test engineers have to pass the driving exam before they are accepted?
Some of them already had license when we began, and one of them, as far as I know, just passed the exam. Yes.
You know, like some test engineers write the test cases following to the specification, and maybe your test engineers do it following the rules of driving in Russian Federation. The actual question was about testing as well. As quality assurance engineer, I'm really interested in how this whole system
is going to be tested.
Yeah. Do they test the... I doubt that they would have to test the vehicle itself, because it is a final thing which is also on the market. But what about the hardware, software? Do you have any ideas or maybe plans?
First of all, we haven't done it yet, but as far as I understand, you can debug each module in a separately, and we also have our We will. That's why we're building our. That's why we want to build our simulation module, because there are different kinds of simulators, and some of them are used to test your car in restricted conditions. For example, you're modeling your car with упрощенно, excuse me, and you try to build a road situation when it's going to react somehow, and that's how you test it. It's the first one of the approaches, and the integration tests are going to be held, I believe, in our production site, because our company has a. We also produce electronics for ourselves and for other companies. And there are 2 production sites, one of them in our head office, like engineers live on the 3rd floor, and the line at the second one, there is a very short cycle. And the second line is in Yanina, and we have a whole site, and we tested our previous car, we have another one. And that's where we were testing the first one, that's where we're going to test the second one I'm talking about today.
And the second question, we all know that people are not perfect, and they drive with lots of mistakes, and probably sometimes they misuse the rules of and the regulations of driving for a special purpose. And about the self-driven car, the software may have some bugs.
Policies.
What if this situation happens and there is a bug in the software, and
Who will be responsible, right?
yeah, and a mistake from the human driver? Who is responsible? And if there is a not simulation, but if there is a way to resolve this problem in real case, like the quick off of the car, the quick switch off.
Have you ever read a Scarlett O'Hara history, like Gone with the Wind?
Yeah,
Yeah,
one of my favorite books.
Yeah. Yes, you will think about it tomorrow. We are advancing step by step. It's going to be the next step, and first of all, for the very first time, we're going to ride with a human driver, and whatever happens, you know whose fault it was.
Okay, thank you. That's great, and I think that would be a great project in future.
Yeah, thank
There's
you.
lots of cases, interesting things.
Oh my, so many questions.
Yeah, thanks. Thank you very much. It was amazing, and I see that the task is amazing. A lot of difficult, smaller tasks and difficult solutions. My question was about lidars.
Lidars, yeah.
Yeah, maybe it's not very close to your work, but maybe you address this question to your engineers and later, write in chat the answer. Because I'm interested, you said that it's very expensive and that the Lexus is the cheapest part. And is there any tendencies in lidars to be, cheaper?
Yeah, there are tendencies, and I thought I mentioned it anyway. Yeah, since there are moving parts, there is a desire in the market to make a lidar without moving parts, and there are solid body lidars promising to appear in mass production. It doesn't use moving parts; it uses solid body technologies inside, and these are cheapest. But in the very beginning, they're going to cost like. I heard, maybe I'm mistaken, but I heard that they're gonna cost like thousands of rubles too, but not so much. Like I've read the number 300,000 as I remember. Okay. And we're now not buying the lidar for this reason, because we were contacting the guys who produce solid body lidars, and they said they're going to launch their production site in 2019, and we were waiting to buy a cheaper ones.
Thank you very much for the answer. And I just want to ask you maybe to make more talks when about and ask you to talk more about the during the progress of your project, and maybe more about this computer vision task and machine learning and something like that, and about, it's very interesting because you are inside the core of the project, and you know some interesting problems, and that's not the theory, that's the practice. I will be very glad and happy if you make more talks later. So yes, thank you very much again.
Can I add something to your questions and comments? I've recently watched a report from Yandex, and they have closed development. They have many people, but they are closed. And the guy was so simple, and he put it like, oh, I want to talk about autonomous car today, but I can't talk about Yandex, so I'm going to talk to you about Google and Tesla instead. So and yes, we are open, and we can open up for every part of our production, yes.
So I have a question based more on like transportation side, so I don't know if you as a developer know that, but for cargo transportation right now there are a lot of solutions to automate some things, like a lot of oversized cargo cars don't have steering wheels, for example. But I don't know if there's any research towards self-driving car, for example, for transportation. So it seems like these two parts are moving, they are not synchronized. Mm-hmm. So maybe do you have an idea why is that? Because it would be obviously useful to take working solutions from one part and move it to like from personal car to professional cars.
Are you talking about autonomous trucks or something? Грузовой транспорт.
For example, trucks.
You're talking about commercial transportation of goods, for example, from one part of the country to another?
Yes, including like I know a lot of on the like trucks for oversized goods, mm-hmm. which are like really, really huge. Mm-hmm. And it's really, a lot of the optimization is there. But it doesn't seem to be connected to like cars like this, usual cars.
Yes, actually, I'll split my answer into two parts. Actually, there is another company in St. Petersburg who's building an autonomous. They build autonomous trucks. That's what they do. They call it Arrival, and that's actually one of the branches. So yes, there exist people who do it, even in St. Petersburg. And the second part of my answer is going to be like this. The most obvious application for autonomous driving is actually not a personal transportation. It's actually a public transport. The most convenient way to apply it is to apply it to city buses, because they have a fixed, they have a track which is perfectly defined in the city, and you have to put in less resources to make it automated. That's it.
Okay. Hi.
Yes, hello.
Sorry for my ignorance.
But
is there any difference in the work system between left-sided traffic and right-sided traffic? I mean, like in UK, Cyprus, and Thailand, and things like this. Because, you know, car maybe will wait another cycles here, mm-hmm. and in different countries it will be here.
Yeah, certainly. There is a difference. There is local differences from country to country, and it doesn't concern the only the side of the road you're driving. It concerns also the signage you have on roads, because every country has a different set of signs, for example, and when you're training your neural network to find and to recognize those signs, there actually are local differences, and that's why maybe manufacturers who are trying to achieve some level of autonomousness exist in different countries, and I believe that for sometimes maybe is going to be quite local. Yes, maybe.
Thank you.
It's my view of the field, my personal one.
Hello.
Yes.
I think there is a problem that a lot of cars on the roads nowadays. So if these cars will be autonomous, it won't resolve the problem. So I think it will bring more benefits if you focus on public transportation from the beginning. So what do you think about it?
Yes, probably yes. And I was talking about infrastructure in the end of my speech, because certainly I believe that governments should interfere with cars manufacturers. We certainly need help from governments, and we need special road regulations for autonomous transportation. And what your question, actually, what you're asking about, is you're asking about the government intervention into these fields, because we cannot change public transportation and apply those technologies to it without the government. So.
Okay, thank you for the talk. I have two light questions.
Yeah, sure.
First of all, about HD maps. How are you going to get them? You want to take pictures yourself, or is there a database? Well, that's the first one.
Yeah. We were discussing the question, actually. It was a hot theme for us for a while. And we were trying to contact the map providers, and so far we haven't found anyone who would provide up coverage in Russia. And the problem is with HD map is that it has to be constantly updated, because once you ride the road, you see one situation, and the second time you ride in the road, it's a different situation. Maybe something changed, and you always have to have your car riding in the area and building your HD map. So we're thinking right now that if we do not find a map provider, we will try to build our own, and we will move forward step by step, trying to build our first local map of the area we are riding in, and using this map for our purposes. And the second part, actually, it's the if there's going to be a public transportation and the area is going to be developed further, there will be map providers we could be in partnership with. So we're just trying we'll try to build our own and try to make partnership with someone else. Yes, if they appear.
Thank you.
Because we have time.
And the second small question, you were talking about this vehicle-to-vehicle
communication,
and
yes.
vehicle-to-infrastructure communication. Yeah. What is your prediction? How many years do we have to wait?
Actually, I don't know myself, but my boss, he wanted to arrive here at Pi Ladies. He was asking me to make Maria +1. And right now he's in Moscow in conference called AutoNet, and he said that he's going to discuss the question of vehicle-to-vehicle communication with colleagues. Yes, so this is in progress. And I cannot make a prediction. Maybe sooner, maybe later. But it doesn't require autonomousness to be built. You actually need to put an electronic device on every car, or just on a significant amount of cars, so that you know the situation on the road. It can help autonomous cars to orient themselves, but it also can help ordinary drivers. That's it. So no, I don't know. I can't prognose like this.
Well, I'm taking the last question as usual. It's not about the project, but it's about your team. What's the most funny or like fucked up story for now you had with this project? Choose like the best one and share with us, please.
I'll share two with you. We just purchased the car, and it was parked in our yard, and yeah, and we were very excited to see it in our yard, because we were choosing it for a long time. We had a public poll to choose the car. Yes, everyone in the company was choosing the car, and I asked Alexander, my boss, can I please sit in the car for a while to to feel what it is to sit in my future, to sit in a Lexus in a luxury car? And he's like, okay. And it was parked near the wall. So when I was, you know the ending of the story. But when I was going outside of the car, I scratched it at the wall, and I. Yes. So I put the very first scratch in it. Yes.
All right, guys. Thank you very much. Great questions, great answers.
Oh, thank you.
Right now, it's like most difficult part. You need to pick one that is.
Oh my.
That is your favorite.
Actually.
You can only pick one.
Yeah, there was a question at the very beginning, and I didn't have a pen with me. But there was a question that I said I'm going to write down and ask our engineers. Yes, that was it. That's you.
All right.
Well, that's it, because I didn't know the answer.